Hello and welcome to Jonah and Miel's final project. We're going to go over a handout in which we're going to be covering the chi-square distribution. So the topics of our handout are going to be the characteristics of chi-square, equal expected frequencies, unequal expected frequencies, contingency table analysis, as well as problems. So a quick bullet point here on the characteristics of chi-squared. The main things are that it was created by a mathematician named Carl Pearson in the late 19th century. But the main thing we're going to focus on is right here. The chi-square distribution is non-negative, positively skewed, and based on degrees of freedom. And so the first thing that we're going to focus on today is the equal expected frequencies. So this is testing whether the expected frequencies is going to be equal to the observed frequencies. And so FE is going to be our expected frequencies, and FO is going to be our observed frequencies. So as you can see, this is our formula below, and our degrees of freedom is going to be k minus 1, whereas k is the number of groups or categories. So we're going to hop right into our first example here. So Miss Jackson owns a toy store in Victoria. She has started selling bouncy balls in 6 different colors, as you can see: pink, yellow, green, blue, purple, and orange. So in the first week, she had a total of 180 bouncy balls that had been sold, as we can see right here as well. 27 pink, 9 yellow, 16 green, 30 blue, 75 purple, and 23 orange. So Miss Jackson wants to know if she can conclude that the bouncy ball sales are the same in every color. And we're going to use a 0.05 significance level, and we're going to be using the equal expected frequencies. So I'm just going to hop over. I already finished the example, but I'm just going to show you what I did. So right here, as we can see that we have the observed sales and the expected, so it's equal expected frequencies. So we did our chi-squared analysis, as you can see here. So we're going to minus the expected from observed, squaring that and dividing by the expected. So we're just going to exit out there. And so we get our total, which is the 90.667. And then we conclude into our step 1, where our null hypothesis is the observed number of bouncy balls equals the expected number of bouncy balls. And our alternative is that they're not all the same. And our degrees of freedom is our number of categories, which is 6 bouncy balls minus 1. And as stated before, we are the 0.05 significance level. So as we can see, we are going to choose the chi-square distribution, and the critical value, as we can see, is our degree of freedom with our significance level. I'm just going to pop back over here. So as you can see, we're going to be using 11.07 as our critical value. So there it is as well. So step 4 is forming our decision rule. So if our chi-test value is greater than our critical value of 11.070, we will reject the null hypothesis. And as we calculated earlier, it is in fact greater than our critical value, so we will reject the null hypothesis because it is greater than that. And we can conclude that the number of bouncy balls of the observed may not equal the number of bouncy balls expected.
Expected frequencies, the hypothesis test helps us determine how well a set of observed data fits with the expected outcome. In this case, however, the hypothesized proportions are not equal. Our null hypothesis will state that there is no difference between expected and observed frequencies, and our alternative hypothesis will state that the observed and expected frequencies are in fact different. The steps to calculating are the same as above, as well as the formula. So we will go over question number 2. And the question is, Starbucks reports the following data concerning the amount of coffees sold in a day. 45% of coffees are sold from 8 a.m. to 10 a.m., 15% are sold from 10 a.m. to 12 p.m., 30% are sold from 12 p.m. to 4 p.m., and 10% are sold from 4 p.m. to 8 p.m. A survey of 500 Starbucks customers returned that 197 purchased coffee from 8 a.m. to 10 a.m., 85 purchased coffee from 10 a.m. to 12 p.m., 174 purchased coffee from 12 p.m. to 4 p.m., and 44 purchased coffee from 4 p.m. to 8 p.m. Can we conclude that the survey is consistent with the information provided by Starbucks using a 5% level of significance? So step 1 is to state our null and alternative hypothesis, which in this case are that the observed coffee sales are the same as the expected, and our alternative is that they are not the same. Step 2 is to calculate our degrees of freedom, which is still k minus 1. In this case, k equals 4, minus 1 gives us degrees of freedom of 3. Our critical value using the chi-square chart is 7.815. Then we will state our decision rule. So if the chi-squared value is greater than the chi-critical value, 7.815, we will reject the null hypothesis. Step 3, we multiply the observed sales by the expected percentage to get the expected sales. We do that for each time frame of the day. And then we calculate chi-squared using the formula, same as in example 1. And then we find that our test sample chi-squared returns a value of 9.38, which is greater than the critical value of 7.815. Therefore, we will reject the null hypothesis. A contingency table is very similar to the unequal and equal expected variances, or equal expected frequencies, and it is used to determine whether two characteristics are dependent or not. Each observation is first separated into two traits, then the expected frequencies are calculated for all observations. The expected frequencies are calculated as row total times column total over grand total. And the degrees of freedom are calculated as number of rows minus 1 times the number of columns minus 1. After that, we follow the same steps involved in the previous hypothesis tests.